Section 6.2 involves simplifying expressions where you use the laws of exponents. They're the exact same laws of exponents that we had in that introductory section to chapter 4. And actually, in order to get this first page together, really it's copied verbatim from that other set of notes. Since they're the exact same things, it's just that now the exponents don't have to be integers. Right now they can be fractions, right? You can have rational exponents. That's the only difference. But other than that, all of them still work, and they all still work exactly the same way. So that's nice that we can kind of base what we're doing in this section on stuff that we've already done before. And it's very, very consistent. So for something like number 1, where we have 16 to the 2/3 times 16 to the 5/6, we have the same base of 16, but then that's when, if we're multiplying, we can add the exponents together. So we could say, well, then this is going to be 16 raised to the power of 2/3 plus 5/6. And then in order to combine those together, you need to get a common denominator, which would be 6, right? So you could rewrite the 2/3 as 4 over 6 if you multiply by 2 over 2. So we'd have 16 to the 4/6 plus 5/6. And now we can add them together. And we can say, well, then that's 16 to the 9/6. But that reduces, right? Common factor in the numerator and denominator, we can rewrite that as 16 to the 3/2. And then this kind of goes back to the last section. I would do the root first. So I would do the square root and then raise it to the 3rd power. So we'd have the square root of 16, then cubed. The square root of 16 is 4, so this is 4 cubed, which is 64. All right, and then with number 2, we're dividing. We have the same base, and that's where we can subtract exponents. So then we can write this one as x raised to the power of 3/4 minus 1/5. And we'll have to get a common denominator. So it looks like that's going to be 20. So we'll have to multiply 3/4 by 5 over 5 and multiply 1/5 by 4 over 4. So then, let's see, we're going to have 3/4 times 5 over 5 minus 1/5 times 4 over 4. So that's going to be x raised to the power of 15/20 minus 4/20. So that's x to the power of 11/20. Or if you'd rather write this like with a root and a power, so if you want to write it as like the 20th root of x to the 11th, that is the same thing. I would probably just leave it as x raised to the power of 11 over 20, but in the homework, they might ask you to write it with a radical, so you can, right? It's an equivalent expression, so we can do that. Let's see, other laws of exponents, power to a power, so then we'd have to multiply the exponents together and say, well, then this will be 4 raised to the power of 3/2 times 5/3. And if you look at what's going on in those powers, you could cancel out those 3's and say this will be 4 to the 5/2. And so then I would do the root first, so square root of 4, then to the 5th power, but the square root of 4 is 2. So this is 2 to the 5th, and that's going to be 32. All right, number 4. Now we've got a product being raised to a power, so then you can just distribute that power. So we could say, well, then this will be a to the negative 3/2 to the 8th times b to the 1/4 to the 8th. And then in both cases, we've got a power to raise to another power, so we can multiply. So negative 3/2 times 8, 3 times 8 is 24. So that'll be a raised to the power of negative 24 halves times b raised to the power of 8 fourths. But those simplify. Negative 24 over 2 is negative 12. 8 over 4 is 2. So, all right, well then this is going to be a to the negative 12th times b squared. But then we want to write the answer with a positive exponent, so we got to bring that a term down, or that a factor down, and we'll end up with b squared over a to the 12th. And that's the final answer here. Okay, number 5 looks like it's got a lot going on. And I guess we've got some multiplication, and we also have an exponent. So order of operations, you have to do the exponent first. So that x to the negative 4/3, y to the negative 2, that's just going to stay there out front for the moment, because we've got to distribute that exponent of 4/3 first and deal with that. So the x to the negative 4/3, y to the negative 2, for the moment is just going to stay there out front. And then if we distribute that 4/3 that's all the way over on the right through that product, then we would have x squared to the 4/3 times y to the 1/2 to the 4/3. All right. So now I guess that since this is all multiplication, we don't really need the parentheses anymore. So we can say, well, then this is x to the negative 4/3 times y to the negative 2, and then times x to the 2 times 4/3, but that's going to be 8/3. And then 1/2 times 4/3 is 2/3, right? Half of 4 is 2, so half of 4/3 is 2/3. Right, so we'd have y, so 2/3. And then I'm just going to rearrange the order. So the two factors with a base of x are next to each other, like this. So if we had x to the negative 4/3 times x to the 8/3 times y to the negative 2 times y to the 2/3, then with the two factors with a base of x, we could add those exponents together. We can do the same thing with the y's. So we're going to get x to the negative 4/3 plus 8/3 times y raised to the power of negative 2 plus 2/3. So then that's going to be x to the 4/3, and then y to, it would be negative 6/3 plus 2/3, which would be negative 4/3. So then to write this with a positive, or I guess with all positive exponents, you have to bring the y down. So we'll end up with x to the 4/3 over y to the 4/3. Or, if you prefer to have it written this way, x over y raised to the 4/3. That would also be a reasonable way to write out that answer. All right, so that one was sort of long. I think 6 is shorter. I hope so. I don't know if I have enough space if it is longer. All right, so with 6, we have the same kind of thing where in the numerator, we have a product being raised to a power, so we'd have to distribute that power first, and then after that, we can worry about the division. So first things first, distribute that power in the numerator, and we're going to have 2 to the 5th times x to the negative 1 to the 5th, and then times y to the 2/5 to the 5th. And then in the denominator, we're just going to have x squared, y squared. So we'll worry about that denominator in a minute. All right, so let's see what we can simplify in the numerator first, where we've got powers raised to other powers and things like that. So 2 to the 5th is 32, right? That came up a few minutes ago. And then x to the negative 1 to the 5th, we can multiply the powers together, and that's going to be x raised to the power of negative 5. Then 2/5 times 5 is 2. So you'd have y squared. And then that's going to be over x squared, y squared. And now we can do that thing where we subtract the exponents since we're dividing, right? We got the same base. So the 32 is just there, right? I mean, I guess you could argue it's 32 over 1. If you want to think of there being a coefficient of 1 in the denominator, that is true. But then we'd have x raised to the power of negative 5 minus 2. And then we'd have y raised to the power of 2 minus 2. So that means we're going to have 32x to the negative 7th times y to the 0. But y to the 0 is just 1. So we'll have 32x to the negative 7 times 1, or just 32x to the negative 7th. But then we've got a negative exponent. Got to fix that. So bring it down into the denominator. And we'll have 32 over x to the 7th. And that would be the answer. All right. Next is if we've got some roots, and if you convert those into expressions that have rational exponents, they might simplify kind of nicely. So we're going to find out. Let's see. So we've got the 10th root of 9 to the 5th. Well, if you rewrite that, you could say that that's 9 to the 5th raised to the power of 1/10. But then we can multiply the exponents together and say that that's 9 raised to the power of 5/10, but 5/10 is 1/2. So this is 9 to the 1/2, or the square root of 9, which is 3. And we'll be able to do kind of similar things with these other ones too. So like with 8, we can rewrite that as negative 125 a cubed b to the 9th raised to the power of 1/3. And then we've got a product raised to a power, so we can distribute that power of 1/3 and say that that's going to be negative 125 to the 1/3 times a to the 3rd to the 1/3, and then times b to the 9th to the 1/3. Okay, so let's see what we've got here. The cube root of negative 125, that's just going to be 5. Well, it's going to be negative 5, right, since it's a negative 125 there. Then we're going to have a raised to the power of 3 times 1/3, which is 1. And then b raised to the power of 9/3, right? So I guess really we've got a to the 3/3 and then b to the 9/3. But 3/3 is 1, 9/3 is 3. So this is going to be negative 5ab cubed. Okay, number 9. Looks like we got a couple of things to rewrite. So with number 9, we're going to have x cubed to the 1/7 in the numerator, and that's going to be an x to the 1/2 in the denominator. But then we've got a power to a power in the numerator, so we can write that as x to the 3/7 over x to the 1/2. And then same base in the numerator and denominator, so we can subtract exponents since we're dividing. And we can write this as x to the 3/7 minus 1/2. And we'll have to get a common denominator, which looks like it would have to be 14. So we'll have x to the 3/7 times 2 over 2 minus 1/2 times 7 over 7. So that'll be x to the power of 6/14 minus 7/14. And so that's going to be x raised to the power of negative 1/14. So to write that with a positive exponent, we have to put it in the denominator, 1 over x to the 1/14. Or if you want to write it with a radical, 1 over the 14th root of x. All right, so one of those right? Like either of those I think would work as a final answer. 10 looks a little crazy, and it's actually not that bad. But it looks weird, right? Because you have a root underneath another root. But then you think, well, we can always convert the roots into rational exponents. So underneath the radical, that's an x to the 1/4. But we're taking the square root of that. So square root, you can rewrite as a rational exponent of 1/2. But then we've got a power raised to another power. So this would be x raised to the power of 1/4 times 1/2. And 1/4 times 1/2 is 1/8. So you have x to the 1/8, or if you want to write it with a radical, the 8th root of x. See, wasn't that bad, even though it looks a little crazy at the very beginning. Turns out not to be anything too wild. And then number 11, this is interesting. We have radical 2 showing up as a power, but we have a power raised to another power, which means we can multiply them together. So this would be 5 raised to the power of negative radical 2 times radical 2. But when you have radical 2 times radical 2, that's radical 2 squared. So we'll have 5 raised to the power of the negation of radical 2 squared. But when you square radical 2, you just get 2. So this is 5 raised to the power of negative 2. Rewrite that with a positive exponent. You'd have 1 over 5 squared. Bring it down to the denominator. But then 5 squared is 25. So this is 1 over 25. And that's the answer. So another one that looks like it might be crazy because we got the radical 2's and the exponents, but it actually works out pretty well. So this section, almost everything just rides on all the laws of exponent stuff that we would have had in chapter 4. It's just now those exponents can be rational, right? They can be fractions. They don't have to be integers.